Alright, in order for our monster to understand its environment, it's going to need to know something about where it is on the map and what's around it. We can use the location value from the map that we set up already, right here. And just so we don't have to keep saying loc.x and .y, we'll just say int x equals loc.x and y equals location.y. Since it isn't a lot of code, it'll be easy to know what we're talking about here. So based on the motion, the monster will make decisions. We'll start with idle, case idle, break. In fact, let's just put all our cases in here first. So we're going to have idle, walk and run will be the same decision process. Break there. Case for act dots next will be jump, attack, and ouch. As our monster remains stationary and idle, we'll count with time. If time is greater than total time, then we'll say target velocity.x equals, and then we'll put some random speed here. So we're going to change his velocity so he starts walking or running to some random amount. We'll make a method for that so we can reuse it. Get random speed. And the other thing we need to do is include a target velocity, and then he'll accelerate towards that velocity. Going up to our variable declarations or fields. After position of velocity, we'll add a target velocity here. Vector to target velocity. Okay, so now we have a velocity goal. Let's go back down here, just above update AI. We'll add a little private method here. Float get random speed. X is game1.rnd for random. Randomize a number between 0 and 12 minus 6. So it'll span from -6, speed in -6 going left, or +6 going right. X is greater than 0, X is less than 4, X is equal to 4. That's probably not the best way to do it. We do the same thing here. If it's less than 0 and it's greater than -4, we really should be using ands for this instead of 2 ifs. Oh, and this should be -4 here. And we better return that velocity. Alright, so after a certain amount of time, he'll start moving in a direction at some slightly randomized velocity. If we're coming back into idle, we want to reset this stuff. So if last motion is not equal to current motion, which is idle, then we'll say that time needs to be reset to 0, so we can start the count all over again. And we'll count to some number between 50 and 140. Let's copy this here too and use it in walk and run so he can change his speed every once in a while. So I'll have him reset those. And I put these separators in here so it's really easy to identify which case you're looking at, and you can even hit Control F and type in I space D and then you'll find idle right away. Makes it easy to find them, easy to see what's where, so I would recommend that. So if his mode is, we'll start with wander. Go time plus, just like the idle, and after a certain amount of time, we'll reset the time to 0. So we're just saying total time is equal to game1 rnd.next. We'll go 90, 160. Let's make this one a little longer, 80, 160. We don't want an idle too long, so that will be smaller. So we'll say target velocity, just like with idle, get random speed. If the total time, and this is all going to be dependent on whether this random number actually got higher than, we'll say 150. If the total time is greater than 150, then we're going to say that he's just going to stop if he happens to be within that top 10. So every once in a while in wander mode, he'll start idling. And we'll have it switch to idle when his velocity is 0. If it's under 110, so like the bottom 20 that he can be, we'll change the mode to mode.patrol. So at least that way he can switch to another mode. And what's he going to do when he's in patrol mode? Say else if mode is patrol mode, mode.patrol. Again, we'll have to keep track of time, how many cycles we've gone through. If it's greater than total time, say time equals 0, and we'll do the same thing. 90 and 160. So it'll get a new random time if it goes beyond that amount, and it's just going to stay in patrol mode in the meantime. If we're in the bottom 20 again, when it randomly picks a number, then we're going to go back to wander mode. So all we're really doing is randomly picking how long we want him to be in a certain type of mode. So when jump is first triggered, we can find that out just by saying motion not equal to last motion. Then we'll set his vertical velocity, his jump. We'll say minus game1.rd.next. And we might want this to be an indexed parameter based on the monster type, but we're just going to keep this simple and have them both work kind of the same way. So the jump velocity will be somewhere between -6 and -12, because there's a negative in front of this random number here. That'll make this negative. And we'll just copy this wander code down into here so that if he's jumping, can still change his speed even when he's jumping. Let's just compress this a bit, say 80, 160, and we're not going to care about the patrol. We're just going to adjust his velocity to 0 so that he'll be kind of standing still, going back to idle mode if it's greater than 150. So there's a chance when he's jumping that he could go into idle mode. For our attack motion, we'll just check to see if the player's done playing the animation, and then we'll switch back to idle if it is. Copy that, put that in ouch also. So there may be other things we might want to add to these to make them distinct, so I'm not going to combine them. Now let's set it up so that he can achieve his target velocities. If our velocity.x is less than target velocity.x, and velocity.x plus equals 0.5 f. We'll accelerate towards that target rather quickly. If velocity.x is greater than target velocity.x, we'll say velocity.x minus equals 0.5 f. If velocity.x equals 0, and if motion's not jump, then we can say motion equals act.idle. That way, if he's in the middle of jumping, you don't want to set him to idle. You can let him finish the jump animation. So like right here, it sets the target velocity to 0, and right here, and if it actually reaches 0, then he goes into idle. Otherwise, if the velocity is not 0, and the motion actually is act.idle, then he shouldn't be in idle mode. So we'll say motion equals act.walk. By doing some of this out here, I kind of eliminate having to repeat it in all the different states over here. So if type equals type, monster type, mouster, the mouster actually has an action called run. So we can say that the motion will be act.run. I'll just call this section here basic motion changes. And then we'll start another section down here that's more focused on the actual AI. So we'll say decisions. First of all, what kind of decisions is he going to make while he's on the ground? And we'll go with different decisions depending on what mode he's in. So we'll need a switch for that. For running away mode, we'll make it the same as wander mode for his basic decisions. It's just that he's going to be doing it at a different speed. And he'll probably start off in a direction in the opposite way from your character. Otherwise, the decision process is pretty much the same. He's navigating his terrain. Put a break here, and we'll put it in the case for mode.patrol. First of all, if he's going left, if target velocity less than 0, so he wants to go left. Now we'll need to know whether the tiles around us are solids or spikes. So let's put in some helpers to help us decipher the tiles around us. We'll go up above the update AI class, and we'll add in a helper called solid. Boolean solid int x int y. If x is less than 0 or x is greater than or equal to map.tileswide, first we have to handle whether it's not something that we're allowed to check. Y is less than 0 or y is greater than or equal to map.tilesHigh. If tiles x, y dot is solid, return true. That's really all there is to this. We're just saying, is this tile solid? With this little safety check on the front of it. And we better make sure that by default we're returning false. We'll just copy this little helper here and paste it, and we'll make one for spike. Let's call it spike. And the only difference is right here, spikes, return true. Okay, so we'll check if the tile to the left, x minus 1, y, and it's not spikes. So just to make this very clear, we'll just make this local scope is spike equals spike, x minus 1, y. So if it's not is spike, then we can make a decision. And I'm going to make sure I put lots of comments in here, because otherwise it's going to be hard to decipher. But what we're doing here, oops, I put this in the wrong spot, is we're saying if this is an obstacle that is not a spike, just a regular obstacle, then we'll see if we can jump over it. So if, and we'll add another helper too, so we can check a range of tiles to find out if we can jump over this region. So we'll say contains empty at x minus 1 to the left, starting at y minus 4, going to y y down to y minus 1. So can we jump over or onto? Is there something to the left we can jump onto, being that it's all solid to the left, or at least it's solid in the left tile that we checked. So let's make a contains empty method that can check a range of tiles between some y value and another y value. Obviously this is the top one, this is the bottom one. So above update AI, we'll add a contains empty, boolean contains empty, taking the x value, starting y value, and next y value. I suppose I could add a summary to this to make it clear, but if x is less than 0, x equals 0. And if we're just going to cap it, if y1's less than 0, we're going to say y1 is 0. And if the x value is greater than equal to map.tileswide, x is equal to map.tileswide minus 1. Let's copy that, paste it here. So the bottom y, y2, and that's assuming we made y2 the bottom one, might not be the safest assumption. Actually, you know what? To be on the safe side, let's do this. If y1 is greater than y2, then y1 equals y2. That should be fairly safe now. Let's pull this back to here. If y2 is less than y1, why didn't I do this first? Okay. Let's just take this here, put it up here. So if y2 is less than y1, we can swap them. So int temp equals y1, y1 equals y2, y2 equals temp. And now we know y1 could never be greater than y2, so we can take this out of here. I paused it for a moment, and I decided to just replace these right here with these instead, because that way for sure these values are being clamped between the ends of the map. Okay, let's go int y equals y1 to y plus plus while y is less than y2. If not solid at x comma y, so that would be empty, return true. So as soon as we find an empty tile within that span, we can say, yep, there's an empty tile somewhere within this span here. So the monster can go ahead and try to jump. Chances are good he'll be able to jump with success and get over the obstacle or get on top of it. Otherwise, we're returning false.